Hello, good morning. This is the third lesson for our hydraulics and this is Pitot Tubes. Okay? Last time, pinag-aaralan natin yung um, venturi meters which is the flow measurement device. Sinusukat o ino-observe niya yung conversion of energy from one form to another, from potential to kinetic, as we vary the cross-sectional area of the stream. Okay? Ngayon, pitot tubes naman. This is also a measuring device, pero ang sinusukat nito. So, ito yung definition niya. So, a pitot tube, also known as pitot probe, is a flow measurement device used to measure fluid flow velocity. So, the pitot tube was invented by the French engineer Henri Pitot in the 18th century and was modified to its modern form in mid-19th century by French scientist Henry Darcy. Okay, so the concept came from Henry Pitot. So, kaya sa kanya napangalan yung device. And it was later modified, siguro na-improved by Henry Darcy. So, Henry Darcy, maririnig nyo siya o siguro narinig nyo na, sa soil mechanics. Okay, kasi marami siyang ambag sa hydraulics and soil mechanics, o particularly sa flow ng fluid through porous medium, katulad ng soil. Okay? And this is widely used to determine the airspeed of an aircraft, water speed of a boat, measure velocities in certain industrial applications. So, kaya niya sukatin kahit anong mga fluid yan. Okay? Basta ang sinusukat niya, ang main point natin dito is that this device measures flow velocities. Okay? So, this is Henry Pitot. He is the inventor of Pitot Tube. And this one is Henry Darcy. Okay, so and he made several important contributions to hydraulics, including Darcy's law for law in porous media. I think sa kanya yung V equals K, tama ba? Yung V key na formula sa soil mechanics. Okay, so how do pitot tubes work? Okay, so panood natin yung isang video, okay, para i-explain yung concept ng pitot tube. At hindi ko pa napakita yung picture ng pitot tube, so dito na lang.
Do you know how to measure the velocity of this water? After watching this,
So this one is a stream of fluid. Okay, moving fluid. So with the pitot tube, masusukat natin yung actual velocity ng stream. Okay, so let's know how.
video, you will be able to and understand about Pitot Tube and the concept of stagnation pressure. Consider a piezometer tube. Piezometer tube is just used to calculate the static pressure. By measuring the height to which a column of the liquid rises.
Pause muna natin sandali. This one is a piezometer. Okay, so a tube inserted doon sa stream, that one end is open to the atmosphere. And kung ano man yung taas niyan from the center of the stream hanggang dun sa taas kung saan naman siya tumaas yung tubig dyan sa may piezometer, yun yung kanyang pressure head, tama? So, pressure head indicates kung gaano kalakas yung tulak ng tubig doon sa kanyang boundaries, tama? And this is the potential energy of a fluid, okay? Mas malakas yung pressure dun sa stream, ibig sabihin mas bursting yung conduit niya, mas malakas ang tulak niya dun sa conduit. Siyempre, mas malakas din ang tulak niya ng tubig doon sa piezometer. Mas tataas ng mas maigi yung tubig doon sa piezometer. Okay? So, let's continue.
Against gravity. The fluid is static, relative to the moving fluid. Hence, it is normally termed the static pressure. The pressure height would be same, considering the flow is steady and incompressible. But what if we replace?
Okay, this one is the Pitot tube. Okay? That is a tube that has a bend. May bend siya, commonly 90 degrees. Tapos, open yung top and open din yung other end. The other end, which is yung kulay blue dyan sa video, that is inserted to the stream and papasok yung tubig dun sa butas na yan. Okay? And syempre, as you can imagine, aakyat siya doon sa Pitot tube. Okay? So let's continue.
It with a Pitot tube? the column height of the water will increases. And this extra height is called the...
So yan, katulad na na-imagine nyo kanina, pumasok yung tubig dun sa pitot tube at syempre, bukod sa pressure na tumutulak, diba? Diba sabi natin, the static pressure doon sa point na yung in-insert ng piezometer kanina at doon sa point kung saan pumasok yung tubig doon sa pitot tube, parehas lang yan. Parehas lang yung static pressure dyan. Okay? Pero as you can observe, yung tubig doon sa pitot tube, mas mataas ngayon doon sa piezometer. Let's continue the video at tingnan nyo pa yung explanation.
Dynamic pressure, caused due to stagnation pressure. When the water particle enters the Pitot tube, its velocity will convert to dynamic pressure. And stagnation pressure is the total sum of static and dynamic pressure. So the
Oh, wait. Anong sabi doon? The right... teka, ba't nawala yung tubig doon sa ano? Sa kanang, doon sa pitot tube. Anyway, hanggang doon yung tubig doon sa may dynamic pressure. Ang tawag daw doon yung stagnation pressure. Pero bakit stagnation pressure? Continue pa natin.
Stagnation pressure represents the pressure at a point where the fluid is brought to a complete stop. Now let us apply the Bernoulli equation and derive...
Nope, ano raw yan? Merong point doon sa pitot tube na ang velocity ng fluid is 0. At ang tawag mo dyan sa point niyan is stagnation point. Ibig sabihin, at that point, the fluid inside is already stagnant. Okay? That's why 0 ang velocity niya.
The formula for stagnation pressure. For that, let us write point 1 and point 2. Velocity at point 1 is the velocity of flowing water v, whereas velocity of water at the head of Pitot tube, that is point 2, is 0. The datum height z1 and z2 is 0. Now solving the equation with those value we get. Oh, look!
Wait. Okay, so dito ginamit yung Bernoulli's energy equation. Okay, so point 1, kinancel na nga pala natin yung elevation head kasi parehas lang sila ng elevation. Okay? Sa point 1, we have the static, or we have the potential energy na pressure, and we have the velocity head kasi at point 1, the fluid is still moving. Okay, so let's continue. Sorry, yung point 2 pala, kinross out na yung velocity. Bakit? 0 ba ang velocity dun sa point 2? Oo, 0 yan. Kung hindi mo ma-imagine, i-explain pa natin further mamaya. Okay, so let's continue.
We get the pressure at point 2, that is stagnation pressure, is sum of static and dynamic pressure. Now we can measure the velocity of moving water v, if we know the dynamic pressure. And it can be easily calculated by measuring pressure head. Static pressure is same for both points, whereas stagnation pressure, or the total pressure P2, at Pitot tube is same. Please subscribe for more fluid mechanics.
Okay, so yun. That's how Pitot tubes work. Okay, pero explain pa natin sandali. Konti na lang. Bago tayo mag-proceed sa... Kasi yung kasunod nito is problem solving na. Kung papansin nyo, simple lang ang concept ng Pitot tubes. Right? So, dyan mo tayo sa whiteboard sandali. And let's try to discuss it one more time bago tayo mag-problem solving. Di ba meron tayong stream? Okay, this is a stream of tubig. Okay? Pwedeng closed conduit, nasa loob ng pipe, or nasa isa open stream lang. So, kahit ano. Okay, so syempre, let's say at one point, we have our pressure gauge here. Okay? So, we know the pressure head of the fluid at this point. That's point 1. Okay? Now, we need to determine the velocity of the flow. Okay? Without actually measuring the discharge. Kasi kung makasukat mo yung discharge dito sa stream, so syempre, divide mo lang by area yun, then you have the velocity. Pero we will be doing this without determining discharge. Right? So, gagawin natin, mag-i-insert tayo ng isang Pitot Tube doon sa stream. So, Pitot Tube ay ganito. Okay, so yan yung ating Pitot Tube. So, syempre, pag bagong pasok pa lang siya, wala pang, tawag dyan, wala pang tubig dyan. Okay, so let's say napasukan siya ng tubig. Okay, so ito yung mga tubig. Syempre, ito na, isang tubig lang yan, nag-alakbay siya doon. Punta, pumasok na siya dito sa may, tawag dyan, sa may Pitot Tubes. Okay, so let's say naandyan na siya. Okay? Ngayon, syempre, may mga fluid pa doon sa likod niya na susunod na papasok doon sa Pitot Tubes, right? Tapos, syempre, mag-i-stack sila dyan sa loob ng Pitot Tube. Okay? Hanggang sa yung huling fluid na papasok doon sa Pitot Tube, hindi na siya makapasok. Bakit? Kasi imagine mo, itong mga nakahinto na yan. Okay? So, syempre, to keep that fluid in this level, dapat may tutulak dito. Tama ba? Tama? Kasi syempre, kung walang tubig na tutulak dito sa isang opening, babagsakin pabalik pa ganun. Tama ba? So, ibig sabihin, for the fluid to be in this level, para manatili siyang ganyang kataas, mayroong tubig na tumutulak sa kanya dito. Okay? At yung tubig na tumutulak sa kanya dyan sa may point na yan, yun yung tinatawag natin na stagnation point. Okay? So, parang ito yung mga tubig doon sa Pitot Tubes. Ayan. Okay? Tapos, yung tubig na naandun sa stagnation point, so ito siya. Ayan, tinutulak niya yung, basta. Tinutulak niya yung tubig para hindi sila mahulog pabalik doon. So, para hindi sila bumalik doon sa stream. Okay? Kaya, yung kanyang velocity is equal to 0 because he is holding that water na pumasok doon sa Pitot Tube. Okay? So, ang energy niya, ang kanyang kinetic energy is 0. Tama? Sa stagnation point, that is 0.2. Okay? Pero by Bernoulli's energy equation, sabi natin, the energy at any point of the stream, the sum of their energies, potential and kinetic, is equal, neglecting losses. Tama? So, dito sa point 1, okay? Sa point 1 dito, masaya pa yung fluid dyan, palakad-lakad lang. Basta yan. Okay? So, syempre, meron siyang potential energy because he manages to push the boundaries of the conduit. So, potential energy check. And syempre, dahil gumagalaw pa siya, ang velocity dyan is, syempre, meron din siyang velocity. Okay? So, ang energy niya is pressure plus velocity. Pagdating sa point 2, wala na siyang velocity. Kasi itong point 2 na yan, hindi na siya gumagalaw. Okay? Kasi tinutulak niya na lang yung tubig dun. And, wala na. So, ang meron na lang siya is potential head. Ibig sabihin, yung buong energy dito, the point 1, ay na-convert sa puro potential energy na lang because the fluid at point 2 is not moving. Okay? Okay. So, kung gagamitin natin yan ng BEE from point 1 to point 2, pwede natin sabihin na the pressure head plus the velocity head at point 1 equals that pressure head at point 2. Okay? Okay, so tingnan natin. With these values, ang tanda mo na ang kailangan natin i-solve is yung velocity ng string, which is v sub 1. Okay? So, this is checked because this is known. Itong p sub 2, ito naman yung problema mo ngayon. Okay? Ano to? Ano yung pressure dito? Okay. So, gagawin natin, ito na yun, next step. Ano itong pressure dito? What is the pressure at this stagnation point? Okay? Naalala mo ba yung lesson mo sa fluid mechanics? Ano yung, tawag dyan? Pressure ng tubig. We have to determine the pressure at this point. Paano mo yan kukunin? Diba ano yan? If this is H below the water surface, diba ano yan? P equals gamma H. Tama ba? Unit weight of the fluid times H. Kasi kung gaano kalaki yung dumadagan sa kanyang fluid, kung gaano kataas may dumadagan sa kanyang fluid, yun yung sukat. Kung ano yung pressure at that point. Tama ba? So, eto, you only have to know kung gaano kataas yung itinaas ng tubig doon sa may pitot tube. Doon sa may pitot tube. Okay? So, yan. So, ibig sabihin, etong P sub 2 na yan, so P sub 1 over gamma plus V sub 1 squared over 2G equals P sub 2 is gamma of the fluid over H, kung gaano man kataas to, divided by gamma. So, di ba, ang dali lang. Kasi ang mangyayari, cancel. So, you know the velocity or the pressure at this point, check. And this is H. So, ayan. Kunin natin yung velocity. V1 squared over 2G equals H minus P sub 1 over gamma. Okay, so V sub 1 squared is, teka, wait. So, ayan, equals 2G times H minus P sub 1 over gamma. Tama ba? So, V sub 1 equals square root ng, this is 2GH, this is P sub 1. Di ba na to? Gamma is rho times G. Density times gravity. Tama ba? So, maka-cancel ito. Cancel. So, 2P sub 1 over rho. Okay? So, yan. So, that is our formula. Kapag kukuha ka ng velocity sa isang stream, you only have to know the pressure at point 1 and the height kung ano yung itinaas ng tubig doon sa may pitot tube. Okay? Or kung ikaw ay halimbawa, nagsusukat ka na yung kaya na naglalaro ka sa baha. Okay, ito yung baha. At sinukat mo yung pitot tube, nilagay mo yung pitot tube dyan sa stream. Paharap doon sa stream. Okay? So, ang mangyayari, ano yung pressure sa point 1? It is 0. Kasi, ano siya, open to atmosphere. When P sub 1 o when your stream is open to atmosphere, walang pressure dyan. Hindi ang formula mo lang sa velocity is square root lang ng 2GH. Tama ba? Okay. So, ayun. Pero, syempre, kung may pressure ka, kung open yung stream mo is open to atmosphere, di i-recommend na gamitin mo na lang to. Okay? Pero kung yung stream mo is not open to atmosphere, katulad nito, nasa loob ng pipe, then maganda, gamitin mo na lang ito. Okay? Or, isa pang paraan para magawa mo yung formula for this setup, ganito. Kaya na, consider nating point 2 is ito, yung stagnation point. I-consider naman natin to, yung tubig dyan sa may taas. Okay? Yung umakyat, so doon sa may pinakataas nung pitot tube. Okay? So, let's say that is point 3. Okay? So, observe natin. Pwede naman kasi nating sabihin na, bulit natin to the stagnation point. Doon naman tayo sa may point 3. Ito. Si point 1, ito. May pressure, may velocity. Okay? Ngayon, ano yung nandun si point 3 sa taas? Si point 3, walang pressure. Kasi, open to atmosphere yan eh. Yung dulo ng isang pitot tube. So, pressure is equal to 0. May velocity ba? Wala rin. Kasi, ano siya eh. Hindi na siya gumagalaw dyan eh. So, eto si point 3. Yan. Yung hayahay doon sa may taas ng pitot tube. Okay? So, parang nasa taas siya ng lahat ng fluid doon sa pitot tube. Eh, anong energy ni Anong energy ni point 3? Wala. Wala ba? Hindi pwede yun. Kasi pwede nating sabihin na, burahin ko to pwede nating sabihin na, ganito. Pwede tayo mag-Bernoulli's energy equation from point 1 to point 3. Okay? Ibig sabihin, the energy at point 1 is all converted sa energy ni point 3. Ano ba yung energy ni point 3? Ang meron siya is yung elevation head. Ibig sabihin, lahat ng energy niya rito sa point 1 na-convert into elevation head pagdating dun sa point 3. Okay? So, if this is the datum line, so energy at point 1, pressure, plus velocity, okay? 0 ang kanyang elevation head. Energy sa point 3, no pressure head, no velocity head, pero meron siyang H. Okay? Yung kanyang elevation head. So, yun na. So, all you need to know is pressure dun sa point 1 and pressure doon sa, o yung height na kung saan tumaas yung, tawag dyan, yung fluid doon sa may pitot tube, and you can now solve for velocity. Ganun lang kadali. Okay? So, I do not recommend na kapag ka pitot tube, ang may isip nyo agad is velocity head equals square root of 2gh. Kasi this only works if and only if the pressure at point 1 is 0. Ibig sabihin, you are not confined into a closed conduit. Ibig sabihin, nasa malaya kang stream. Pressure at point 1 is equal to 0. Pero if you have pressure at point 1 na hindi 0, then I recommend na bumalik ka dun sa pinaka-basic na equation. BE muna. Okay? So that is our introduction doon sa lesson natin na Pitot Tubes. Okay? Ito yung gusto kong matanim sa inyo. Ito yung Bernoulli's energy equation, yung concept ng stagnation, kung paano gumagana yung Pitot Tube. Okay. So let's get back to the problems na kailangan nating solve. Siguro cut ko muna yung video dito para hindi masyadong mahaba yung mga pins. Yung sunod na video, that is the examples. Okay?